Hi, welcome to QuBites, your bite-sized pieces of quantum computing. My name is Rene from Valorem Reply, and today's episode is a little bit more technical, and we're going to talk about Microsoft Quantum Development Kit, the QDK. And for this, I'm honored to have a very special expert guest today, a Dr. Sarah Kaiser. Hi, Sarah, and welcome to the show. How are you today?
Pretty great. How are you, Rene?
I'm great. I'm really good. Can you tell us a little bit about yourself and your background as it relates to quantum computing?
Sure. So I've been working in the field for probably almost 10 years now. I did my PhD in kind of experimental quantum computing, hardware and technologies. And now I kind of work in the quantum open source software space. So developing new software tools, platforms, and the community around really the tools that are going to enable us to take this technology to the next level.
Wow, that's impressive. So folks, another PhD here on the show, but don't worry, Sarah does super good job in explaining these things so that also myself can understand it. So don't worry about it. And by the way, Sarah, you also have a Twitch channel, and you just wrote a book, right?
Yeah, so I'm also really excited about sharing with people like how cool I think quantum computing is. So I regularly write code for quantum computers live on Twitch, and yeah, I have a book with Dr. Chris Grenade coming out called Learn Quantum Computing with Python and Q#. So
nice.
Yeah, it's aimed at basically developers to kind of get them take their development skills and programming skills that they already have and kind of bootstrap them into writing code for quantum computers.
Nice. And thanks for dressing appropriately today with your book shirt. And I mean, look at the earrings, folks. It says Q#, right? Which brings us actually to one of the first topics we wanted to cover here. And in a previous episode, you might remember that we talked with Fabrice Frajon from Microsoft about Azure Quantum, and we touched just briefly a little bit on the Quantum Development Kit, the QDK, and the language Q#. But let's talk more about it, right? So first of all, Sarah, what is the QDK and Q#, and how are they actually related to Azure Quantum?
Yeah, so that's a good question. So the Quantum Development Kit kind of describes a collection of tools. So there's a new language, Q#, as you mentioned, which is really a domain-specific programming language for quantum computers. So just kind of like in the classical computing stack where we have like GPUs and FPGAs, often we have specialized languages that are kind of what we can use to best leverage the capabilities of those specialized devices. Mm-hmm. So kind of like you have CUDA for GPUs. You can think of Q# as a similar sort of domain-specific language that allows us to really efficiently leverage the capabilities of these quantum devices. And so the Quantum Development Kit more broadly basically includes all the support tools, the compiler, the libraries, things like that, that can really make using Q# it kind of completes the workflow, if you will. So yeah, like I mentioned, there's some libraries for doing like quantum machine learning, quantum chemistry, and like kind of, I'm a Python developer by training. And so it's kind of like all the things that I expect, I don't want to have to implement this. So let me look up phase estimation. There's a library for phase estimation, or there's features in a library I can use. So yeah, it's really kind of gives you that, I guess what I would call like more traditional development experience with editor plugins. So there's also VS Code and Visual Studio editor extensions as well. And so, I can literally switch from doing like C# to Q# to Python all with the same kind of experience.
And I'm sure you're also well-versed in all of that stack, because you're actually also an MVP, right, for development technologies, right? So we almost forgot about it. She's also Microsoft's MVP. It's like the whole bucket of so many things. Oh, man, that's really impressive, actually. And so we talked about the QDK and Q#. One thing I saw today, there's also this quantum intermediate representation, right, which is this new kind of intermediate representation similar like to LLVM when we're dealing with C++, or the IL kind of intermediate language when we're dealing with .NET, right? And so maybe I got it right, maybe I got it wrong, but maybe you can confirm. So that's helping me to basically have this kind of middle layer before I go down to the hardware, right? So I have more flexibility to targeting different quantum computing machines. Is that somehow correct?
Yeah, I think you got it pretty much exactly right. And you hit on a topic that I'm currently very interested in. So I love so the kind of Q team recently put forward an open source proposal for this quantum intermediate representation. And as you mentioned, just like LLVM, this is a common thing where we'll have tools that, will compile to some sort of intermediate representation, and then we kind of build other tools to take that intermediate representation to whatever else. It's kind of like a many-to-many connector sort of representation. And so we haven't really had one in quantum. We've had different proposals. We've used things like OpenChasm and Quill, but one of the main challenges in quantum computing is often the applications that we want to use or use quantum computing for are what we call hybrid applications, where you have a bunch of classical computing that you want to do along with, you're basically using the quantum computer like a subroutine in your classical algorithm or program that you're running.
Yep.
And so it's been hard to have an intermediate representation that really encompasses both the classical and the quantum pieces. And so that's like kind of one of the big strengths of QIR, is because it's literally a fork of LLVM. You basically get all of the LLVM infrastructure along for free, and then we basically add it adds some additional components that allow you to express kind of what the quantum device should be doing.
Nice.
So yeah, it's a really neat thing. And I think, especially in terms of our ability to extend the quantum ecosystem, the quantum software ecosystem, right now, it's kind of challenging because not a lot of the tools talk together. And so having some sort of common representation, given everybody agrees to use it,
Yes.
Standards are great, right? Until we need another standard. But but yeah, so I think, as someone who likes to build a lot of tools and stuff that help other quantum programming stacks and stuff like that, it's going to be really great, I think.
And in terms of like the whole market or the whole industry right now, I mean, I think there's a lot of other solutions and libraries and tooling for quantum computing. What is the impact and adoption of the QDK and Q# that you're seeing in the community of the quantum computing world, basically?
Yeah, so the way I kind of like to view it is like, well, first of all, we need a diverse ecosystem of tools. Like, we don't really do classical computing with just C.
Yeah.
I mean, maybe some people would like to, but I don't want to. But we have tons of different tools for different reasons, because they make things, they make the particular task you're trying to do easier. And so kind of the way I see it is a lot of the other tools currently in our quantum ecosystem are much closer to the hardware. Which is great because we have devices that we need to actually be able to communicate with, to characterize, things like that. But it's kind of like the difference between writing in assembly or BASIC versus writing in Python. And so like kind of Q# sits at the other end of the spectrum, where it really is designed and focused around expressing quantum algorithms and quantum programs. So that really makes it easier to say, if I'm interested in doing like circuit optimization, or I'm interested in applications, this is going to be kind of a higher level language that's going to be easier. It's going to have things like phase estimation all pre-wrapped up as a thing that I can just call, as opposed to having to think at the gate level and build things up. That's not to say, I mean, we need all of these tools because there's different tasks to be done at the different levels. But as someone who likes to think on the application side, taking a paper or taking an algorithm that I see kind of in the wild, if it were, as it were, and then wanting to go try and implement it, it's a lot, I've found it a lot easier to use Q# to do that sort of task.
That's
so
awesome.
That's kind of like how I see everything kind of lay out in the ecosystem.
Yeah, that's actually pretty fantastic that Microsoft is putting a lot of effort in the development tooling here, and building the new ground basically for higher programming languages and so on. And yeah, I totally see the benefit as well. That's awesome. How can people get started actually if they want to adopt Q# or QDK?
Well, you're talking to the right person.
Exactly. Your Twitch
there
channel.
There are a lot of good resources out there. So probably, I mean, as always, the best place to start probably is at the docs. So docs.microsoft.com/quantum. So we also have a community group for Q# users. So we're about a couple hundred folks right now, but we kind of work together and work on different projects and stuff, building simulators, compilers, things like that. So that's a really great place for support. like there's a quantum computing stack exchange. So you can actually like do just like I would for Python, Google, how do I, sort a list and then find the answer, then copy paste from Stack Exchange. So you can do that already.
So you can like type, how can I implement Short's algorithm? And then you get copy and pastable code in Q#.
Yeah.
But
I haven't literally tried that query, but I know like, so like also the book that I've written recently, Learn Quantum Computing with Python and Q#. We have all of our samples on GitHub. One of the things that makes me most excited about working in kind of quantum computing and especially the open source area right now is we're at a huge growth point. We can develop the software kind of independent of the hardware. We know what we need from the hardware. And so like we can, design the API, but we don't have to necessarily have the others. We can build simulators, we can do all kinds of stuff to kind of test that, but we can really build up what does it mean to be a quantum software developer, whether it's an industry or an academia. And so, having that all be open source as a part of the ecosystem, I think is really, really important. And there are a number of good organizations that are kind of helping to further that as well, which are also good resources. So there's the Quantum Open Source Foundation. So they basically they have some of the best lists of resources and stuff that kind of collated for like what projects are out there. So I also work at the Unitary Fund. So that we're a nonprofit where basically we give out micro grants to folks that want to actually develop quantum, like whether it's Q# or Qiskit or Cirq or whatever open source project you want, we want to actually kind of help fund and make that ecosystem grow. So that's kind of our mission.
Sounds great. Well, we're already at the end of the show. Thank you so much, Sarah, for joining us today and sharing your insights. It's very much appreciated.
Oh, definitely. I always love talking about quantum stuff.
Yeah, I mean, it's so much fun. Well, thanks everyone for joining us for another episode of QuBites, your bite-sized piece of quantum computing. Make sure to follow Dr. Sarah Kaiser on Twitter, on Twitch, and get her book, of course. I will definitely go to Amazon and order it. So yeah, again, thanks for joining us, and everyone, watch our blog, follow our social media channels to hear all about the next episodes. Take care, be safe, and see you soon. Bye-bye.
Bye, everybody.